On this worksheet, we are going to practice balancing redox reactions. I've got 3 examples, and each one we're going to balance in acidic solution and also in basic solution. Step 1 is to divide our reaction into half reactions. To do that, we're going to take the 2 products and we're going to write them into separate chemical reactions. So I'm going to start with Fe2+, that's going to be reaction number 1, and Cr2O7 2-, that's going to be reaction number 2. Now what I need to do is take my products and I need to match them up with these half reactions, and we're just going to do that logically. Fe3+, where does it make the most sense for that to appear? Should it be the product of the first reaction? Should it be the product of the second reaction? We want to match up the iron with the iron. That is definitely what's most logical here. So we'll put Fe3+ with the first half reaction, and Cr3+, that makes the most sense to keep with the chromium, so we'll put Cr3+ here. Now our redox reaction has been divided into 2 half reactions. The next thing that we need to do is balance each of these half reactions one at a time. I'm going to start with the first half reaction. The first thing that we're going to do is balance the atoms. And when we balance the atoms, we have to do this in a particular order. First, we balance everything other than oxygen or hydrogen. In this case, it's the iron. Iron, we have one on the left, one on the right. We're good to go. After that, we would balance the oxygens and the hydrogens, but we don't have any in this case, so I'll skip that step for now. The last thing that we have to do is balance the charges, and this is definitely the trickiest part of redox reactions. Right now, we have a 2+ on the left and we have a 3+ on the right, so that is not balanced in terms of charge. We need to have the same total charge on the left as what we have on the right. The only way that we can balance charges is by adding electrons. We could add electrons as reactants, or we could add electrons as products. When we add electrons, it's going to make the charge go down because electrons are negatively charged. So to balance the charge, what we have to do is find the side that has the higher charge. In this case, it's the right-hand side, and we need to bring that charge down so that it matches the charge on the left-hand side. Our right-hand side has a +3 charge, and we need to bring it down to a +2 charge to match the left-hand side. To bring it down by 1, we just need to add 1 electron. +3 minus 1 is going to be equal to +2, so that's matching with the left, and this half reaction is done. Now we're going to move on to the second half reaction. First, we balance everything other than oxygen and hydrogen. We've got 2 chromiums on the left, but only 1 on the right, so we need 2 chromiums on the right as well. Now we're ready to balance our oxygen atoms, but oh, look we don't even have any oxygen atoms over here. If we need to add oxygen atoms, we do that by adding water. So we're going to add water molecule as a source of oxygen, and then let's balance it. Now we have 7 oxygen on the left, and we have 7 oxygen on the right. The last thing that we need to do is balance our hydrogen. We have a total of 14 hydrogen on the right, but ooh, no hydrogens over here. To add hydrogen atoms, we add them as the H+ ion because this is in acidic solution, which means that we have H+ present. That's what it means to be acidic. We need a total of 14 of those hydrogen ions, so we're going to put a 14 right there. And now we have, let's double check, 2 chromiums, 7 oxygen, and 14 hydrogen. The last thing that we need to do is balance the charges. So let's add up our total charge on the left-hand side. We have a -2 + 14. -2 + 14 adds up to a total of +12. And on the right-hand side, our total charges are a +6. We have 2 of those +3 ions. Remember, what we need to do is find the side that has the higher charge, that's +12, and we need to add electrons to bring it down to the lower charge. So that means we need to drop that charge by 6. We need to add 6 electrons. If we add 6 electrons, that's going to take the charge on the left-hand side down to a +6. So now this half reaction is done. The last thing that we need to do is combine these 2 half reactions together to give us our overall balanced equation. When we combine the half reactions, we want to do so in a way that these electrons are going to cancel each other out. And the only way that's possible is if we have the same number of electrons on the left-hand side as we have on the right-hand side. So currently we have 6 electrons on the left side of this half reaction, and we only have 1 electron on the right-hand side of this half reaction. We want to have the same number of electrons on each side. We want to have 6 electrons in this half reaction up here. We can't just change the stoichiometric coefficient of one thing in a reaction. We've got to change everything the same way in order to keep things balanced. And sometimes the way that this is written is we say we're going to take this whole entire equation and just multiply everything by 6, which is exactly what we're doing. We're multiplying all of these stoichiometric coefficients by 6. 1 times 6 is 6, so there we go. We are now ready to combine these two half reactions. So we're just going to add them up the way you would add up a math equation. We're going to take all of the reactants, everything that is on the left-hand side of both of the equations, 6 Fe2 plus and Cr2O7 2 minus and 14 H plus and 6 electrons. That's all of our reactants. And then we're going to do all of our products, 6 Fe3 plus, 6 electrons, 2 Cr3 plus, and 7 H2O. It's almost done. The last thing that we need to do is just make sure that there is nothing on the left-hand side that's also identically present on the right-hand side. 6 Fe2 plus is not the same as 6 Fe3 plus. They have different charges. Cr2O7 2 minus is not on the right-hand side. 14H plus, also not on the right-hand side. 6 electrons, those will cancel. You should always be able to cancel your electrons. And this is done. Now the second part says balance the above reaction in a basic solution. If we're dealing with a basic solution, my suggestion is that you start by balancing it as if it was in an acidic solution. So what I'm doing now is just copying my balanced equation in acidic solution, so we can work from there. 6 Fe3 plus 2 Cr3 plus 7 H2O. If we have a basic solution, this means we cannot have H plus present because H plus is our acid. So let's kind of make a note of that. H plus is our acid. Our base is OH minus, no H plus allowed. So if we have a basic solution, what we need to do is, on paper, get rid of this H plus, and the way that we're going to do that is by adding OH, and we are going to add the exact same amount of OH as we have H plus, so that all of the H pluses are going to get canceled out. Now, we don't want to just add 14 OHs randomly to the left-hand side of the equation because that would unbalance this equation. You can't just drop 14 oxygens and 14 hydrogens and 14 negative charges in there. So whatever we do to the left-hand side, we need to do the same thing over on the right. This keeps the equation balanced. The 14H plus and the 14OH minus together, they make 14 water molecules. So I'm going to cancel those guys out, and we're just going to have 14 water molecules over here on the left. Now, before we say, oh, we're done, this looks good, we do want to double check. We just added a whole bunch of water molecules to the left-hand side. Do they cancel out? Do we also have water molecules on the left? Looks like we do. We have 7 water molecules on the left. We can remove those 7 water molecules on the left, and we also can remove 7 of the water molecules on the right. So this equation has gotten super messy, which is pretty normal. I'll copy it one more time. 6 Fe2 plus Cr2O7 2 minus plus 7 H2O makes 6 Fe3 plus 2 Cr3 plus and 14 hydroxide OH minus. All right, let's try equation number 2. First thing we need to do is separate these into half reactions. CH3OH, that's one of our reactants. And if we look at our products, what makes the most sense to match up? Let's keep the carbon atoms together. So we're going to make CO2 right here. And let's just balance this one while we have it. First, we want to balance the carbons. We have 1 on the left, 1 on the right. Then we balance the oxygen. We have 1 on the left, 2 on the right. The way that we balance oxygen is by adding water. So now we have 2 oxygen on the left and 2 on the right. Now we need to balance our hydrogen. We have 1, 2, 3, 4, 5, 6 on the left. We balance our hydrogen by adding H+. So now we have 6 on the right. And our last step is to add electrons to balance the charges. The left-hand side of this equation has an overall charge of 0. The right-hand side has an overall charge of +6. Find the higher charged side, add electrons to that side to bring its charge down so that the left side and the right side have the same charge. Next half reaction, we have Ce4+, and that is turning into Ce3+. Cerium is balanced. We don't have any oxygen, we don't have any hydrogen, so now we need to balance the charges, find the side that has the higher charge, add electrons to that side so that the charge on the left is the same as the charge on the right. Last thing we have to do before we combine these together is make sure we have the same number of electrons in each half reaction. We need 6 electrons in this half reaction, so we're going to multiply every stoichiometric coefficient by 6. And now we are ready to combine. Write all of our reactants, CH3OH plus H2O plus 6 Ce4 plus 6 electrons makes all of our products, CO2 plus 6H plus 6E minus plus 6 Ce3 plus. Take a look at what we can cancel. We should always be able to cancel our electrons, but it looks like that's the only thing that we can cancel this time for this equation. So this is balanced in acidic solution. Now we want to balance that same reaction in basic solution. We're going to copy our acid balanced equation, CH3OH plus H2O plus 6 Ce4 plus makes CO2 plus 6H plus 6 Ce3 plus. To balance this in basic solution, we're going to find our H plus. We are going to add OH minus in the same quantity. The H plus and the OH minus are going to combine together to make H2O, which I'm just going to write over here on the side. So these two are combining to make 6H2O. And then what I'm going to do is double check to see, since I wrote a new molecule here, H2O, I just want to double check to see if I have any on the left and if it can cancel, which it can. So this is going to be changed to 5 H2O. We're going to cancel one water molecule from each side of the equation. We have, ooh, you know what I did? I messed this one up. I made a mistake. I made a fatal error. Let's back up. When we add 6OH minus, I did not add the 6OH minus to the left side. That would have made it imbalanced. Good thing I caught that. So we want to add the OH minus to both the left side and the right side so that the equations stay balanced. Now we can cancel or rewrite the 6H plus and 6OH minus as 6H2O. We can take one water molecule from each side of the equation, which leaves us with 5H2O on the left. Whew. Okay, we have one more example to do. Start by dividing into half reactions. We have PO3 3 minus going to PO4 3 minus. Our phosphorus is balanced. Next, we want to balance the oxygen, 3 on the left, 4 on the right. So we want to add H2O on the left. Now we have 4 oxygen on the left and 4 on the right. And then last, we want to balance the hydrogen. We have 2H on the left-hand side, so we want to add 2H plus on the right-hand side. Now let's take a look at our charges. We have a total of -3 on the left, and we have a total of -1 on the right. -3 plus 2 is -1. We want to find the side with the higher charge and add electrons to bring its charge down so that it matches the left-hand side. -3 plus 2 minus 1 equals a -3, which is what we have over here. Half reaction number 2, we have MnO4 minus going to MnO2. Our manganese is balanced. We want to balance our oxygens. So we'll add 2 water molecules to the right-hand side. Now we have 1, 2, 3, 4, 5, 6, 7, 8 oxygens. Now let's balance the hydrogens. We have 1, 2, 3, 4 hydrogens on the left. We need 4H plus on the right. And let's balance our charges. Left-hand side, we have a -1 plus 4 is a +3 charge. Right-hand side is neutral. So we need to add 3 electrons to the left side. Now we have -1 plus 4 minus 3 is neutral and neutral on the right. Before we combine these reactions together, we need to make sure we have the same number of electrons in each half reaction. We have 3 in one and 2 in the other. We need both to have 6. That's the only way that we're going to get them to cancel. So this right here, we need to multiply everything by 3 so that we can get this up to 6 electrons. We're going to multiply everything by 3. 1 times 3 is 3, 1 times 3 is 3, 2 times 3 is 6, and 2 times 3 is 6. For this one down here, we need 6 electrons, so for this one, we're going to multiply everything by 2. 1 times 2 is 2, 4 times 2 is 8, 3 times 2 is 6, 1 times 2 is 2, 2 times 2 is 4. Now we're ready to combine. 3 PO3 3 minus plus 3 H2O plus 2 MnO4 minus plus 8H plus 6 electrons, those are all of our reactants, going to 3 PO4 3 minus plus 6H plus 6 electrons plus Mn2 MnO2 plus 4H2O. Let's take a look at what we can cancel. We should always be able to cancel the electrons. We'll get rid of those. We also can cancel water. We have 3 waters on the left and 4 waters on the right. So we can remove 3 waters from both sides. That's going to take us down to just 1 water on the right-hand side. Oh, we can also cancel H+. We have 8 on the left and 6 on the right. We can remove 6 H pluses from each side. So that's going to take us down to 2 H pluses over here. That's kind of messy, so let's rewrite it. 3 PO3 3 minus plus 2 MnO4 minus plus 2H plus makes 3 PO4 3 minus. And if you are working on these and you feel like, oh my gosh, I don't know if I might have screwed this up, there's a lot of steps. This one right here is pretty tricky. You can count everything. It should all be balanced. Everything should work itself out. I'm just going to copy this equation down here to do the basic solution balancing. To do that, we want to find our H pluses. We want to add that same amount of OH minus, and don't mess up like I did last time and almost forgot to do the same thing to the left as I do to the right. The OH and the H plus combine to make water, 2H2O. And then once we've made our water, we want to look and see if we have water to cancel out. We can take 1 water molecule away from each side, and here is our equation balanced in a basic solution.